Hello and welcome to Unleashed. I'm your host, Will Bachman, and I am delighted to be here today with Brian Potter, who is author of the Substack Construction Physics, which I've been following for years and I've learned so much from. It's one of my favorite periodicals. And he's the author of the new book, The Origins of Efficiency, which I just finished reading. Absolutely fantastic, 5 stars, really amazing book. Brian, welcome to the show.
Thank you for having me.
So, Brian, in the origins of efficiency, you lay out your core model, as I understand it, has these 5 levers of where efficiency comes from. And you define efficiency as like, how do we make something with fewer inputs? And in your core model, there's 5 pieces: the production method, increasing the production rate, lowering input costs, removing steps, or reducing variability. How did you come up with this model? How did it evolve over time? Were there like levers that you originally thought of and excluded? So I'm curious about how you eventually landed on these 5 levers.
Yeah, so it's interesting. I had spent before I started writing the book, I had spent a lot of time trying to better understand, why some things get cheaper over time, why some things don't, why some industries seem to be a lot more resistant to it than other industries. My background is in the construction industry, hence the name of the newsletter. And it sort of came from a place as to understanding why, construction productivity never seems to increase and why we never get houses and buildings and other things never really get cheaper to build. So I kind of started to explore, all those things prior to the writing the newsletter, and then I got the opportunity to really dive into it and write a book about it. And so very early on, when I started writing the book, right, kind of really before I really had the thesis fleshed out, I would say. And this wasn't obvious to me at the time. I thought I kind of understood this well enough. But then I would write these chapters and be like, oh, this is not really very good. I would send chapters to people and say, don't read that. It's not very good. I clearly haven't grasped this quite right. When I was trying to explain, like people ask, like, okay, what's like, in conversation, what is like the very simple explanation of how this works? What's the elevator version? I couldn't explain it like simply and coherently. So it eventually became clear to me that I didn't really quite have this sort of structure worked out. And how I usually write things is that, for my newsletter, I usually write much shorter things, essays and things like that. And how it usually works is I like just read enough about the topic and sort of think about, write down my list of things that are interesting, things that are like relevant to sort of the subject that I'm writing about. And eventually I have this sort of collection of observations and thoughts about it. And I'm able to sort of condense that into sort of what's the structure that like combines all these things in like the simplest possible way that I can, and then that becomes like the structure of the essay or whatever. And I realized that I hadn't really done that for the book that I was writing. And so it's the first 6 months of writing the book, I was basically like spinning my wheels, and not producing anything that was good and not sort of having converged on this the word core thesis. So I basically just kept reading about it and kept like working through my understanding and kept like coming up with these ideas, and those ideas would divert me towards more things I needed to read about. And then eventually after a lot of iteration of that process, I was able to kind of do the same thing where I had like, okay, you kind of realize like, okay, all these different things that I've seen these different companies do, all these different industrial improvement systems that I've read about it, these sort of same ideas kind of keep showing up over and over again. And I kind of can classify all these different, strategies that I've seen for improving productivity. I can kind of put it in just a few different buckets, basically. And then when you combine those buckets, you get sort of these very efficient processes, which I already knew what the end sort of looked like. I knew what a sort of super efficient process should be. So I was able to sort of connect those observations to what that kind of ended up needed to be. So it was a long and difficult process actually of getting there because I didn't realize at the time that I hadn't quite figured it out. I rushed in without writing before realizing that.
Reading it, it felt to me like part of the sort of the reason of the whole book was almost to get to the last chapter on why construction costs can, for building construction have not decreased. Is almost the whole argument of explaining what drives things, costs to go down for other manufactured goods like television screens or light bulbs. And then you get to this chapter that really brings it all together of why is construction so expensive. Talk to us about that. What's the argument of, what's the explanation that you have of why do building construction costs not go down?
Yeah, so you kind of, you really hit at it when you kind of pointed out that, yeah, there's like these specific levers that you have to pull, specific things that, specific ways that you can intervene in a process to kind of make it more efficient. And if you can do those things, scale up your operations and find cheaper inputs and all that stuff, you can, reduce your costs, your efficiency goes up. But if those avenues for improvement are like blocked, then it's very hard to, to accumulate efficiency improvements in a process and to sort of make it better, make it cheaper over time. And so kind of what I, yeah, realize is that all these sort of different strategies you have to improve a construction process, they're all very, very all difficult. All these avenues are like, blocked or at least have significant obstacles in them. So, an example is like I talk about economies of scale a lot about in the book. That's a historically been a pretty important way that stuff gets cheaper over time. You make more of something and you can make it cheaper. And I kind of dive into the various specific mechanisms by how that works in the book. But it's very hard to get economies of scale in construction. I've sort of written a few essays about this, how you really see very, very little in the way economies of scale. Very, very large home builders have historically not really built their homes any cheaper than very small home builders, for instance. And perhaps maybe that's now changing now with maybe these large home builders may be to the point where they're maybe capturing more economies of scale. But anyway, yeah, so it's very hard to sort of get these economies of scale. And part of it is just, buildings aren't built in large enough volumes to really achieve these, the economies of scale that you can kind of get in other industries. Single family homes are probably built more than any other building in the US. We built like something like a million, depending on the year, single family homes in the US, which is a lot, but it's way less than something like cars, which are built like 15 million, or cell phones, which are like in the hundreds of millions, or, aluminum cans, which are built in the many billions of years in the US alone. And so even, you're already starting with like a much smaller pool, and then that pool gets like whittled down even further for things like, different building codes in different permitting jurisdictions. The US has like thousands of different permitting jurisdictions, and, have different sites and different environmental requirements and all this stuff. And then it's hard to sort of transport buildings and houses are so big that you can't move them very far economically. So your transportation distance can further limits how much scale you can get like in any one individual building operation. So there's all these factors that conspire to make it hard to sort of get um, economies of scale in building construction, and kind of all the factors that you kind of see are a little bit like this. You talked about like input costs as being another one. It's very hard to sort of reduce the input cost of construction. Your two main inputs are just building materials and labor. It's hard to make building materials any cheaper. They're already kind of as cheap as we know how to make anything. It's hard to make labor cheaper because labor costs keep going up, and you can't outsource the construction labor the way that you can, outsource the manufacturing of something like tennis shoes, where I talk about like Nike in the book, which like has continually pursued low cost sources of labor. And so they started out in Japan, and then they moved to Taiwan, and they moved from Taiwan to China, and then moved from China to sort of Vietnam and Indonesia and places like that. You can't really do that in construction. So yeah, again, all that's the sort of recurring theme that you see, is that these specific ways that you have of making a process more efficient and reducing your costs. All those strategies are very difficult in construction for kind of a variety of reasons.
One insight that surprised me from the book is how reducing transport costs were a sort of essential precondition to a lot of the efficiency gains, and that before you talk about kind of in the 19th century how the shift, how the railroads in the US allowed factories to access much larger markets and also get inputs from a wider area and therefore gain economies of scale. Talk to me about that a little bit. That was an aspect of production I never really thought about, was just how transport could unlock the market size.
Yeah, because when your transport costs are really, really high and you can't ship stuff, a long distance economically or reliably, it's very hard to sort of reach like these very large markets. You just can't move your stuff very, very far. And so, yeah, the creation of the railroad and the spread of like, railroad access like widely in sort of like the second half of the 19th century really unlocked a lot of, these really efficient large scale production businesses. 'Cause all of a sudden you could, source your materials from very far away. You could now get them really reliably. So you weren't like, stuff wasn't getting like held up in transit and you weren't having these times when like production would just stop because you couldn't get materials in. You could get it out much more reliably and get it, repeatedly to these, these new major markets. And so after the development of the railroad and when the country begins, tied together and access to these distant locations is much cheaper and much easier, you really start to see a lot of like large scale production in kind of, and in more efficient production in kind of a variety of different ways. So you start to see the invention of these like, what are called like continuous process machines, which can just like, it's a step, it's, production process, which just goes one step immediately after the other, no waiting, no buffering, no interruptions, anything like that. It just continually produces like a huge output of goods. And you start to see the development of these like continuous processes for like, simple manufactured goods once the railroads had enabled these like very, very large markets. So like auto, machines for making like matchbooks or matches and cigarettes and stuff like that start to appear. After the railroad is when you start to see like these really large companies like Sears show up, which can, reach these really, really huge markets. And it's also when you start to see, things like it also kind of enables the spread of new and better technology in kind of an interesting way. I think I touch on this a very small amount in the book, I believe. But for most of the 19th century, the way that U.S. homes heated was with just like, fireplaces with like wood burning fireplaces. And a better technology was like these iron stoves, which were known about and were used, but were like relatively weren't like super widely used, and partly it was because it was so expensive to transport this like really really heavy stove like very long distances. And so but once the railroad comes along, it becomes much more economical to sort of move these stoves long distance, and that's when they like really start to take off. And then also at the same time you kind of see the centralization of production, and so the cost of manufacturing them maybe drops as well. So yeah, the sort of the decrease in transportation costs and make it more reliable was really a big enabler of economies of scale. And we see something, within our lifetime, within the last several decades, with, container shipping reducing the cost of like ocean-borne transportation. And you see like, the rise of these like really, really huge manufacturing operations in places like Southeast Asia, which can now ship their things cheaply all over the globe.
So the book has such a wonderful range of examples of products, some of which are very everyday for us. And you have talk about light bulbs and paper and aluminum and steel and cement, cigarettes, matches, screws, cans, nails often come up, breakfast cereal, solar voltaics, aircrafts. I thought we could do an exercise where we could go through each of the five levers, and perhaps you could share, one story that illustrates that lever to give listeners a sense of what the book's about. And so maybe we could start with the production method. Give us an example where, changing the production method, unlocked efficiency.
Sure. So yeah, production method is just basically essentially the technology that you use to make a given thing. And some technologies, they require just fundamentally fewer inputs, lower cost, less materials for making a given thing than some newer technologies. We find better technology, we can reduce the cost of making something. And so the examples for this that I like are like raw materials, where we often find some like fundamentally better way of like refining some material or producing it or something like that, just because it's, it goes down to like just we find like, the laws of physics allow this like other way to do it. It just fundamentally takes less time and effort. So one example I like is the manufacture of steel, which, is very, very important. Our modern world is built on having like cheaply and widely available steel. In the 18th century up through the first half of the 19th century, steel was mostly made by this very expensive process called the cementation process, where you took iron and you had to put it in these chests with like a lot of charcoal basically, and then just heat the chests over like a period of days. And the charcoal would like make its way into the steel or into the iron, excuse me, and turn into steel. But it was very slow, it was very labor intensive, it was very expensive to make steel this way. And so the result is that steel was like really not used widely. It was used for like some things like cutlery and stuff like that, but it was very, very expensive, and so you couldn't use it for like large scale construction. But then in the middle of the 19th century, a guy named Henry Bessemer invented a new way of making steel, which basically just involved taking molten iron and putting it in like a big, steel tank, essentially, and then blowing air through this tank. And as he blew air, he found out that as he blew air through it, it would, basically create a chemical reaction where it would like convert into the iron would convert into steel. These things were called Bessemer converters. And this was like a much, much easier way of making steel, because instead of like having to like go through the cementation process, which took days to make like a pretty small amount of steel, you could make a huge amount all at once in about 10 minutes. And so this dramatically reduced the cost of steel. And so it was only after like the Bessemer process where you start seeing like steel construction start to become a thing, because now we could produce such steel so cheaply in such large quantities they could use it became possible to sort of build buildings with it in a way that it wasn't before. And there are other enablers of steel construction as well, stuff like the elevator. But so yeah, that's an example. It's just this fundamentally new technology just makes steel just a fundamentally different way than the way it was made before, which just took dramatically less time and less effort and could be much more efficient.
I just reread your Substack on steel, which was from a couple years ago. And on that, there's this amazing, mind-blowing fact about how you're right, to make 1 kilogram of steel took like 250 kilograms of wood, if I remember correctly. Like just imagining how much wood you would have to cut and then transport to make that 1 kilogram of steel. I love the way you put that in perspective.
Yeah, it was, it took a huge amount of wood. You had to burn the wood to make charcoal. It took this like huge amount of charcoal to make the iron and to make the steel. Yeah, so like yeah, until some of these other processes, the Bessemer process, and there are other more efficient processes for making the iron as well. Yeah, these became, made these materials much cheaper. Much could be produced much more efficiently.
Give us an example that illustrates the second lever of increasing production rate of how economies of scale, spreading fixed costs help become more efficient.
Yeah, so there's like lots of examples of this that you can point to. One is that we touched on a little bit is just container shipping, and it's become incredibly inexpensive to produce, or to sorry, to sort of move goods across the ocean via container ships. And in large part, this has become because the container ships have gotten so much larger that the costs have not risen as fast as like the size increase. And so, the cost per container or whatever to sort of move a container across the Pacific Ocean or whatever has like dramatically fallen over time as these container ships have gotten bigger and bigger. And that comes down to sort of a variety of like different specific scaling mechanisms. One is something that's called like geometric scaling, where as you make a object larger, the capacity of it often enlarges faster than the sort of material that is required to sort of make it. So as boats get bigger, they increase in capacity faster than the material that it takes to sort of build them. So a larger boat will use like proportionally less steel than like a smaller boat will use. And so as the the ship cost per container goes down, it becomes cheaper and cheaper to sort of move these containers across the ocean. And there's a variety of sort of, yeah, different mechanisms. You touched on one, fixed cost scaling. And an example of like fixed cost, you spread your fixed costs, some cost that doesn't vary with volume, you spread those, can be more thinly spread over a crust of a wider output. And you kind of see this to some extent with container shipping as well, where it might take a relatively similar crew size to man a small boat as it would a large boat. And so as the boats get bigger, your crew size maybe stays relatively fixed or perhaps close to fixed. And so those crew costs can be spread more thinly as your ships get larger and larger.
Let's talk about lowering input costs. And on that one, maybe you could talk about thread, which I think you say that the cost of thread went down by like a factor of 10, and therefore, any sort of fabrics made out of thread became so much cheaper. How did thread become so cheap? Like a lot of us don't think about, spinning wool and so forth, but that was consumed a huge amount of human labor until relatively recently.
Yeah, yeah. Thread is really interesting, and thread is sort of as an input gets cheaper, but an input is often sort of the product output of some other previous process, and so that's how it is with like thread. It used to take like a huge amount of time and effort. People had to sort of spin this thread, manually, either with like just like what's called like a drop spindle, or they would use like a spinning wheel. But it took lots and lots of effort, like millions of people doing all this spinning to sort of make enough thread to feed into these looms to make fabric, to make, cloth. And really the story of thread is sort of a story of technological change. The very early industrial revolution was about like sort of finding ways to sort of, spin thread and make cloth much cheaper than had been possible previously. There's other interesting examples of input costs that are getting reduced. You often have sort of interesting reductions that are just based on like factors that happen to exist in like a given location that are not necessarily easily movable. And so labor is, a classic example of this. Often other places have like much cheaper labor. If you can relocate your operations to a place that has, less labor cost as less labor as an input, cheaper labor as an input, you can make your thing much cheaper. But there's kind of other interesting examples as well. Like one fun example from the book that I found was that some places that have like a lot of hydroelectricity often have like very cheap electricity. And because the electricity is so cheap there, they often end up having a lot of industries that really use a lot of electricity. So like Iceland, for instance, they produce a very large amount of aluminum because aluminum production takes a very large amount of electricity. And Iceland has very inexpensive electricity because they happen to have all this hydroelectricity, and they have a relatively small population. So yeah, you kind of see these like different like, factors, production factors in different locations can make stuff less expensive in different places. And you tend to see like a reshuffling of global production to kind of take advantage of those things.
How about removing steps? Give us an example of that.
Yeah, this is a classic one. In some ways, this is like the main strategy of making processes more efficient that's taken advantage of in the 20th century. Because you see all these different like ideas, stuff like Frederick Taylor's scientific management, stuff like mass production, stuff like lean manufacturing. All of them have kind of at their core this idea that's like a lot of these steps in the process aren't actually necessary at all. And if we can cut out these steps, all the sort of costs associated with them goes with it as well. There's the classic example, or a classic recent example of this. Elon Musk has famously relayed this story where, he was like, they had some sort of robot that was installing these like mats in the Tesla, and there's all these problems with the robot. They couldn't get it to install the mats properly. They were investing all this time and effort to try to, resolve this issue. But then eventually at some point, he or somebody else asked the question, like, why are these matches even in this car at all? And they basically said, well, they're there to reduce the noise, to sort of be like a noise absorber. And then they ran a test on the car with and without the mats, and there was like no difference in the sound in the cabin whatsoever. So this thing that they thought was like adding value to the car, that was like making the experience of riding the car better, turned out to be contributing nothing of value whatsoever. And so they could just take out the robot, take out the mat, and just eliminate the entire step in the process. And this sort of strategy is like very, very common in like industrial improvement methods. A very, very common one is like carrying something from like point A to point B, and having or like storing something that doesn't need to be stored. This is why Toyota production system and lean manufacturing and things like that, they place so much effort on minimizing inventories and minimizing buffers, which is another thing that I talk about in the book, which is like these stocks of partially produced material that accumulate between different steps in the process, is because all that stuff requires like extra storage, extra handling, extra sort of effort to kind of keep track of. And if you can kind of eliminate these inventories, just, have a, ideal of one piece flow where something flows from one step to the other without sort of this accumulation and buffers and waiting and stuff like that, you can dramatically reduce your cost. And so a fact I mentioned in the book that I stumbled across that was fun, where like in the 80s, Japanese factories with like similar outputs to American factories were much, much cheaper to build because they needed to store much, much less inventory. And so it required a physically smaller factory to produce the same amount of stuff that like these large American factories that were designed for like lots of material storage needed.
I think that you say it's about a third of the size of American factories, which was just mind-blowing to imagine how much smaller the footprint is. Give an example of the last lever, which is gaining control of a process so you can reduce the variability almost a precondition to some of the other levers.
Yeah, so I kind of talk about this in the book, but like a process, any given process, any given series of actions to get some specific output that you're trying to do, it will never be able to sort of work 100% reliably 100% of the time. You're always going to get some sort of like failures to creep in, that are inevitably going to produce output that can't be used or something like that. Nothing can work perfectly all the time. But the more that you can reduce those sort of failures and errors, the less wasteful your production, the less that you're throwing away or having to sort of rework, and the cheaper that your sort of production can be. Sort of an area that is like this is like really, really important is semiconductor manufacturing, where because like your semiconductors, you're making these like really, really tiny devices that require like a very, very precise, you know, mixture of chemicals, right? You have, you're introducing like a very, very small amount of impurities into silicon, and reducing the exact right impurities in the exact right places is what allows like a semiconductor to work. But even, you're talking about like parts per million of atoms, right? And so if you're slightly off, or introduce like a tiny particle in the wrong place, your thing that you're making, your chip or whatever, will not work. And so historically, semiconductor manufacturing often had like very, very low yields. You're talking about like in single, line, coming online, you might be getting like single digit percentage of like a good product for like, when you throw in like the, 95% or something away. And so if you can make your process work more reliably, if you can get like the exact right of like, dopants in your silicon every single time, and you can absorb any stray particles going in there, if you can like perfectly control your process, you can dramatically increase your yields and not be throwing like some huge amount of your product away because you introduce a speck of dust in there or something.
I want to ask you about the evolution of your Substack construction physics over time. The first, you started it, I think, in September 2020, and then for about 3 years, it was very much focused on construction uh, of housing, buildings, and then in 2023, you started opening the aperture and talking about the energy grid and energy tech. And then it evolved to expanded to look at institutions. You talked about Bell Labs and other institutions. And then you've kind of evolved further into even broader topics like innovation dynamics and global production and industrial policy. Tell us a little bit about that evolution, if I have that correct, or correct me, and sort of has it been the initial plan, or has it been more like as you covered topics, you felt, all right, your curiosity led you to other topics? How did that path happen?
Yeah, I think you have the arc basically correct. And I would say at the core, it's always just been about, following my kind of interests roughly. And when I started the newsletter, I had just, come from working at this like very large and well-funded construction startup that had gone bankrupt. And the very, thing that was very top in my mind is like, why did this company that was so well-funded fail? Why is the construction industry so difficult to change? And so that's what I was like really, really focusing my efforts on. And sort of, I spent lots and lots of time writing about that. But then as I started writing about that, I was, exploring these sort of other industries and kind of understanding why they, may have improved or may not have improved more to sort of import those lessons into sort of better understanding of the construction industry. And so I started like gradually expanding my reach that way. And another big one was that, for a while I wanted to sort of, move from the construction startup that I had joined to like another construction startup. And I was sort of using this like writing the newsletter as a guide to sort of help me on that journey, basically. But then what ended up happening was like the newsletter got popular enough that it started kind of getting attention. And one of the places that it got attention was these guys that were starting this new think tank called Institute for Progress that was just basically about how to sort of stimulate industrial and scientific and technological progress in the US. And they were sort of a fan of my work. And so they, asked if there was any way they could sort of help support it. And what they ended up doing was they sort of sponsored it for a year. I forget which year it was. I think it was the first year would have been 2022 or 2023. I would have to look. But then sort of that first year of sponsorship kind of went pretty well. But as I was sort of working with them, I kind of naturally became more aware of and more interested in sort of the topics that they thought were interesting and relevant, which wasn't just, housing and building construction, but, more broadly about like infrastructure construction as well. So when I was, joined them, when they sponsored me, and they gave me a title of like senior infrastructure fellow. So that's kind of when I started to sort of expand my mandate and write more about like infrastructure stuff. And then after a year of being sponsored by them, we sort of had really liked, they said, we like how this is going. How should we, what, fashion should we kind of continue this? And I had really liked how it was going. And then at the time I was essentially like in the market for a job, basically a full-time job. And we basically decided that I would just join them full time to kind of continue to work on the newsletter and kind of continue to work on other infrastructure projects with them. So, so as I joined them full time, it basically became more and more in my sort of enthusiasm to write about some of these topics that were more relevant to them. And then sort of as I was writing, on top of that, as I was writing the book, I kind of went down all these like different rabbit holes of different areas to explore. And that kind of stimulated my interest in more things. So like there's a very big chunk of the book is like talking about like technological progress and how these different processes, the methods of them get better over time. And kind of since then, I've started writing more and more about like technological progress and what sort of how it happens and what stimulates it sort of on the newsletter. And so I've always kind of just followed my interests, but as sort of and I'm very fortunate to kind of just be able to do that. But as sort of my personal context has changed, as I like, have changed from like, working in the construction industry to, working for this think tank. And as I've, written this book and explored these other topics, the sort of scope of things that are interest me, and then I feel like that I'm capable of writing about because as I research more things, that kind of gives me a foothold to sort of jump off into new topics as that has sort of expanded as well. So that's kind of how that has evolved over time.
Talk to me a bit about institutions and organizations as a production technology.
Yeah, it's interesting because like, we think of technology as, like a semiconductor or a nuclear power plant or like some physical arrangement of, matter and energy to accomplish a good thing. But really a technology is like, knowledge of how to sort of accomplish some given thing with some given series of steps. And that can, be embodied in like some sort of physical device, but it also can be embodied in like a series of an organization or a series of actions that people know they need to take. And so organizations like learning how to sort of structure their operations and how to arrange their work more effectively is a very sort of important vector in productivity improvement. I think kind of lean manufacturing and sort of that's associated descendants and cousins and things like that is kind of like a very important example of this, where it improved efficiency not by like creating some new device necessarily or like building some like physical machine or tool, but it really is just like rearranging of the way that people sort of do their work and embodying that sort of those ideas like in the organization itself. And so yeah, I think this sort of like, the sort of way that the work is structured, which exists in, the sort of patterns and behaviors of in organizations is like a sort of underrated aspect of like technology.
I wonder if you could talk to us about any field trips that you've taken and kind of if you visited any steel mills or paper factories or any kind of factories as part of your research. And if so, what did you learn from those in-person visits that you didn't get from the secondary sources or the background reading?
Sure. So I didn't do a lot of research. I'm very much a text guy. That's the sort of, the comparative advantage I have is that I can just spend a lot of time reading a lot of like, old and out of print and often quite boring, books and industrial manuals and all that sort of stuff. So like, I'm, is, it's very thematically appropriate, but I'm very about, having like an efficient research process. And often I find like the most efficient research process is just like read a book and stuff like that. So I just, I've doubled down kind of very hard on that. I would say I do my sort of experience is informed about like, working in the construction industry and especially sort of the route that it took within the construction industry, because I worked on like a bunch of different facets of the industry. I worked for like a traditional consulting engineer where you just like design, buildings and those get built by like, contractors and whatever. But I also worked in sort of a more manufacturing oriented operations because I worked at a construction startup that was trying to sort of build these things, build houses in factories. But even before that, I worked in this field of the construction industry that was called precast concrete, which is basically making these large concrete pieces in a factory and then transporting them to a job site and like, lifting it into place with a crane and then welding it all together. So that kind of is informed, how I sort of think about these different industries as well. But I would say in general, my strategy is like, what's the most efficient way of sort of getting like the sort of facts about how this thing, something works as possible. And I will do that, by reading books or sometimes watching videos about it. And so I will specifically tailor my sort of research efforts towards the things that like that strategy works for. So I will read about the things for which there is a lot of information in books and other things like that. So one reason that I write a lot about Henry Ford and early car manufacturing in the book is because we know a lot about that and it has been written down and documented very, very well. And so you can get a lot of information from that just from reading or from watching for watching videos, not for in some cases, not for Ford, but for other things. And so for the things where that doesn't work as well, I basically don't use those sources as much. So one criticism that I got for the book is like, you don't talk about like China at all. And China, or you talk about it like very little. And China is obviously like the most important, the rise of China and Chinese manufacturing is like the most important large scale event to happen in like manufacturing over the last several decades, and you don't often mention it at all. And the reason that I don't mention it more is because there's just not that many sources that are available to me in text form that I could like get a little information for. It's either not written down at all, it's all either like, in these factory floor managers' heads, or it's, in Chinese language that I don't speak and can't easily find. And so, yeah, I tailor my sort of process to the sort of things that are like, there's a lot of information available in text that I can take advantage of. And I sort of shy away from things where maybe that sort of text is not so easily available.
So on that note, you talk in the book about, there's some more secondary type sources of, histories that talk about the car industry or other industries. But tell us about some primary source that really stuck out to you, like, an actual user manual for a machine or some kind of that you were just alluding to that you recall and was sort of surprising to you or helpful to you, or one of these 19th century 18th century like user guide to the to the steel mill, something like that. Give us some.
Yeah, so an important source and important like sort of, area of research in the book was this field called statistical process control, which was this like industrial improvement and method invented actually at Bell Labs in sort of the, early to mid 20th century. And it's basically this the idea behind it is basically just like you should study your processes and see how they vary over time and find what's causing that variation and try to remove it if you can. And then your process will like work much more reliably. And a really, really useful source on this, a really, really interesting source, is this manual for statistical process control that was for this company called Western Electric, which was the manufacturing arm of AT&T when AT&T was like, the biggest company in the world or whatever. And so they had this manual that, this factory manual basically that says if you're going to go, this is how you sort of set up your factory operations, sort of do the statistical process control and how you can like do these experiments to sort of figure out what the variation is in these processes. And so that manual is like apparently like something of a Bible in like the process control world, and it's like why it became like very widely read by other organizations. And so getting a copy of that and just like reading exactly how like these process control methods worked, and that was explained like really, really well and really, really clearly, was a really, really useful source that I found, and that really shaped my thinking of how these methods work and what makes them work and how you can sort of think about those ideas more broadly.
You were selected into the 17th cohort of Emergent Ventures winners back in 2021. How did that help your progress with construction physics or with your research?
You did do you did do your research. Yes, I was selected for that, 2021. What that did was it helped me sort of take the plunge and leave my full-time job. At the time, I was working as a consulting, engineer at a engineering consultancy and just writing the newsletter on the side. And what it did is help me realize, leave my full-time job. And what actually, at the time, me and my wife were doing, we were trying sort of to investigate this building technology that we thought might be interesting and could, potentially doing like a construction startup around it. And so what that did is it gave me sort of the runway, as it were, to leave my job and kind of pursue this sort of idea and also like expand how I would continue to do the newsletter. And that startup, that idea didn't really pan out for a variety of reasons, part of which was that the newsletter was getting so popular that it just seemed to make more sense to like continue to focus on that, which was already working so well. But yeah, so the transition I made from doing the newsletter part-time to doing it like something close to full-time was partly due to sort of like, yeah, that grant and just, the money and also just like the validation is like, yes, these things that you're doing are valuable and useful, and you should like continue to sort of focus your efforts on them to the extent that you can.
Last question. Now that the book is out, what are you working on next?
Yeah, I have a couple different ideas for kind of new books. I've increasingly been interested in sort of the shipbuilding industry. I started that as using just like as an analogy to the construction industry because in some ways they're so similar. You're building these large structures that are like inhabited more or less. So I have an idea of like I've increasingly like written quite a bit about it, and I have an idea to sort of turn some of those ideas maybe into a short history of the shipbuilding industry. And I have some kind of other ideas that are like less fully developed that I may pursue as well. But a day to day, I'm still focusing on writing just the newsletter, trying to get a new one out, every week or so. Continuing to sort of just follow my interests where they lead, which, as you noted, is now, quite extensive. Lots of different topics that I'm trying to sort of cover and learn more about.
Let's share the link. Tell us, where can listeners find you online?
Yeah, I'm at the construction physics Substack. If you just search construction physics, it will be the first thing that comes up. And the book is Origins of Efficiency. It's coming out on October 14th, available where books are sold. So Amazon and Barnes and Noble and places like that.
Wonderful. Brian, thank you so much for being on the show. And congratulations on the book and congratulations on the growth of your Substack. I think it's more than 60,000 subscribers now, which is incredible. It's one of my favorite things to read, and it was great speaking with you.
Yeah, it was great to be here. Thanks for having me.